good evening. We are going to start the presentation for your task 1, the phase 2, regarding to your selected databases. So as I announced before, you have two options. The first option is if you are not available during the Zoom meeting, so I'm going to turn on your video, submitted video, then it will be your presentation. Otherwise, option 2 is if you are here, so you can present based on your presentation. So when you present, please share your screen, then you guys can unmute, then start your presentation. So please try to do your best to manage your presentation time within 5 minutes, because we have a total 12 submissions, so it may take almost an hour only for the presentation. I'd like to save the class hour, then we can finish on time. Those who want to present live, so please let me know when you are done, then you can use your laptop and share your PPT file. Even though you submitted, you have a chance to select your option for your presentation. Okay, so this is the order of the presentation. I share the screen. So first, let me check the. So okay, so Peter, when I call, so you can just do your presentation. So the first one is Anastasia. Then Anastasia, the live presentation, and the second, Peter. Peter, you can present with your presentation file, and followed by the Tara, the submitted recorded video. I'm going to turn on, and Shiva and Shubham, they submitted the recorded video, and Sai also submitted the recorded video, and Louis also submitted a recorded video, then followed by the Umesh. Umesh will present today, and the race one will present today. The presentation, and Sharma the present, and Tavera present, and also the Bharat the presenter today. Okay, then also the Peter will present today. Okay, the first is I'm going to start the task, the presentation, then you guys can have a time to prepare your presentation. Is it okay, the Anastasia and the Peter? So you guys can take a time to prepare your presentation. I'm going to start from the tab 3, then we are going to continue from the first one. Okay, the first presentation is by the side Inala, the ladies, the NoSQL database. I'm going to share the screen. And then and this is Redis, the NoSQL database.
Remote dictionary server. It is very fast, open source, in-memory, key value data store.
Can you guys hear the sound? I just turned off right now, but did you hear the sound? Please, if you hear the sound, please give me a thumbs up, and I can. Did you hear the sound? Let me quickly check. Great, perfect. Okay, okay, great. So I'm going to continue. And okay.
Which is used as a database, as a cache system, and as a message broker. As it is an in-memory database, it means that the data is stored in the memory but not on the disk. And the interaction with Firebase is command-based. It is developed by an Italian developer and released in the first release was in the year 2009. Based on the recent rankings and stands in the position other key value databases and emulate all other databases including the relational and SQL. A few characteristics of the Redis database. The performance is very high compared to the other databases, and we can access up to 120,000 requests per second. And the Redis is very flexible as it is a NoSQL database. We don't have to use any schema or we don't have to create any tables. We just have to use comments. It is durable as the data is stored in the in-memory as it is by default, but it can also be stored on the disk, and it can also be used as a caching system. It is a cross-platform service and it is supported by many other clients. And coming to the compatibility and scalability, we can understand that from the coming slides. Suppose a user is accessing a data from the database. The user is on the leftmost in the database is the blue color database. And, we can use the Redis as a cache system where the more frequent data can be stored in Redis. And suppose the user is accessing that data, first we will check the Redis. If it is there available on the Redis, we will give it to the client. If not, we will access the database and then give that to the client. In this case, the Redis sits as a compatible system between the database and the client.
Yeah, there is no sound in our videos. There is no sound.
For the Redis, so this improves the performance. So the data structure, these are the basic data structures, and unlike other key value databases, these are available in the Redis, and because of these available data structures, more complex data can be stored in Redis. And these are the applications where Redis can be used, and if we observe most of these, the caching, messaging, the gaming leaderboards, and media streaming, all these requires the main requirement of these is satisfied by Redis, which is having the very quick response time. And this is just because of the in-memory database. Also, the Amazon Elastic Cache offers fully managed Redis for most of the applications, and those applications require sub-millisecond response time. So the biggest advantage of Redis is being very quick, and that is because of the in-memory database. Thank you.
Okay, let me change the screen. Is Tara here right now? Okay, so he's not online. So I have actually a couple of questions for Redis, the database. So I'm going to send, leave the message, the comment on Canvas. So regarding to my questions, so actually my question from the Redis database is the Tara mentioned about it is durable, even though this is the main memory database. Then how? That is a key part that should be described in the research, because that's the conflict. So using memory, so probably it's the volatile, so it's not durable. But how can the Redis database make the durable database, even though they are using the main memory? So that is my quick question. Then, and also second question is, if this is the main memory database, then how does it need? Do we need another database for the NoSQL database, right? So probably it's limited by the size of the main memory. So the Tara mentioned about the 512 byte, a string, for example. So what if we have the much bigger? So then if Redis database doesn't work with the other database sources, so it may be limited. So that is my two questions. So I'm going to ask this question, then hopefully we'd like to hear the answer from the next page. Okay. So next one is we are going to start in order. So Anastasia, you are here, right? So you can unmute.
Anastasia.
Yes, great. So why don't you? I'm going to start the share. Then you can share your screen, and then you can unmute. Start.
Sure.
Great, we can see you. Very nice.
Okay. Hi everyone, my name is Anastasia and I will be presenting on MarkLogic server NoSQL database. And MarkLogic is an enterprise NoSQL database. It is placed 41st in the engine rankings as of October 2020. And it is placed 7th as a document model database. And it's not only document-based, it is a multi-model. As you can see, it's a beneficial mix of many data models. It is started as a data storing XML documents, and now it's storing as a JSON documents as well. And
so which means the XML and JSON files are main data type used in the MarkLogic?
Yes.
Oh, okay.
Yes. Also, it stores in binary as well. And what are the customers of MarkLogic? You can see logos of many, Johnson Johnson, Panasonic, Cisco, DHL, and others. And the most common use of MarkLogic database is for creating a data hub. And some of the examples of applications would be Chevron, that puts together every data record and every piece of equipment worldwide using MarkLogic Data Hub. Means MarkLogic can store a huge size of data, up to 3 petabytes of data in there. And the other example would be the Center for Medicare and Medicaid Services. Utilizes MarkLogic to let millions of US citizens access their healthcare coverage information, having thousands of transactions per second. And NoSQL-like features that MarkLogic has is elastic horizontal scalability, meaning you can add the server to the cluster, remove when need. Really easy to scale. There is no schemas requirement, so you can load the data as it is and access it right there. MarkLogic also provides high availability. Data is available 24/7 for you.
The previous slide. When you are saying the elastic horizontal scalability, what's the exact meaning of the elastic?
It's basically just the fact that you can, I would say it's a synonym to horizontal. You can say that it's just easy to add and remove, and it's also reasonably cheap. That's why they also call it elastic, because it's not expensive in case of MarkLogic.
So do they support the automatic scale up and scale down, or there is manual?
What?
Is the automatic scale up, scale down, or is the manual scale up or scalability?
It's manual.
It's a manual. Okay.
It's a request.
Amazon used the same name, the Elastic Server. That's the reason they are fully automated the scalability the system. So I think they may support such a feature.
But they still recommend that you should you are the one who manages it.
Okay. Go ahead.
I can check on it.
Yeah.
So the other features that MarkLogic has that are not common for a NoSQL database are enterprise-like characteristic. It supports asset transaction, meaning that the data is very reliable in MarkLogic. MarkLogic supports strong security certification, which makes it suitable for many governmental companies that are looking for databases, guaranteeing key encryption and data loss prevention. It also provides sophisticated built-in search, which you you can think of Google-like search, very fast and easy to use.
And also the nowadays a lot of the NoSQL database, they claim the database are the ACID transaction or durable. So, but as we learned before, it's not straightforward to support the ACID in the NoSQL database. So later, when you research more about the MarkLogic server, find this interesting to find how the MarkLogic support the ACID transaction. Okay, it's as we discussed the last few weeks, it's really the overhead to keep the ACID transaction in NoSQL database. And also they say that they are scalable and high availability. So we cannot get all of things in the distributed database. So check how they support such a ACID transaction.
Sure, I read a bit about it. So of course there is this capturing that restrict, and basically what they really saying is that the scalability is really available and like consistent. So within the cluster, but if there are different clusters, then there can be a delay.
Okay. Okay, go ahead.
So the data models that are supported, as I said, it's multimodal database. The main one is, as for me, and the most usable and flexible that they started off is document model. They're able to store structured and unstructured data as a JSON and XML document from text, PDFs to video and image content. There is also semantic graph model available for you to store relationship and facts. They're using RDF triples for that. It's basically object, verb, subject, like Anastasia is student, to store relationships. And they also provide a really interesting feature of relational view of the actual data. The data stays unchanged, but it provides you ability to SQL for querying for your analysis. And as I already mentioned, there is a built-in search that is unified among all of the data models.
Yeah, I also interest in the relational view. It's a new feature. I didn't see such a view. So I'm looking forward to seeing the example of such a relational view later when you implement this database.
Sure. Sure. And installation is pretty straightforward. You download the corresponding installer from the website for your machine. It is recommended to use Linux for deployment, but it is available for Windows and Mac for the development. You start the server, you initialize the instance by going to the port 8001. How you can manipulate the data? You can ingest and query data using Java API, Node.js API, JavaScript, xQuery, Query Console, as well as REST API that can be used almost with any programming language. And you can also query, you cannot ingest data, but you can query via SQL and Sparkle. As I mentioned, using this on-top relational views. And if you want to know more, you can refer to MarkLogic documentation, MarkLogic website. Thank you. Okay,
very nice. I think that you can put a little bit more the contents on your writing or paste. I think that the presentation has much more information than your writing. So why don't you keep documenting such the research, and then hope to see your implementation later. Any question from other students? You can unmute yourself if you have a question or a suggestion. Okay, so very nice, thank you. And next, let me change the Peter, are you ready? Peter is he here? Let me check whether Peter is here. Peter, please.
Sorry, I was on mute. My apologies.
So are you ready?
Yes, I am.
Okay, so I'm going to stop share, so you can share your presentation form. Then after the presentation, why don't you send the Canvas message with your submission?
Okay, great. Can
Yeah.
everyone see my screen?
Yes, it's good.
Okay, great. So good evening, everybody. I chose to work with the Azure Cosmos DB, and so that's the database that we're going to be looking at today. So just as an overall introduction to Azure Cosmos DB, probably the most important feature to know about Cosmos DB is that it's built on top of Azure. So if you've heard of Amazon Web Services or Google Cloud Platform, Azure is Microsoft's implementation of using the cloud. And so because of that, Cosmos DB is actually a fully managed solution. So you as a database administrator, you're not managing racks, you're not provisioning more services at your data center. Azure's taking care of that for you. Cosmos DB is taking care of that for you. So that's kind of a backdrop to understanding why Cosmos DB is actually so powerful. And so with that, here we have, there's really 4 or 5 main features. One is guaranteed speed and scale. So Azure is a global infrastructure in which they have several regions or many regions across the entire globe. And so we'll talk a little bit more about the architecture of Cosmos DB, but Cosmos DB is able to leverage Azure's global infrastructure. Fast application development. We're going to talk a little bit more about this in the characteristics and model section, but essentially, as Anastasia was talking about before, with her database, this is a multi-model database implementation. And so you, as a developer, can leverage all of Cosmos DB's features, but ultimately you have to choose what model you're going to actually use. So are you going to use Cassandra? Are you going to use Gremlin? Things like that. And again, because of the Azure infrastructure, there's a high availability. As we talked about before, it's a fully managed solution. And I guess the final point to note is that because there's automatic scaling, you have significant price savings, because one of the core challenges in running the database operation is cost. And so if you provision too many resources, well, then you have a lot of wasted costs, and if you don't provision enough, that results in a poor user experience and poor availability for users of your service.
I want to make sure the Cosmos DB based on the relational model, one is the free from such a model.
So that's a great question, and so because it's multi-model, you actually have a choice.
I see.
And so you can choose to go with SQL in a relational database model, or you can choose to use SDKs and APIs that use Cassandra, or use MongoDB, or even use Gremlin with the graph model as well.
Okay, gotcha.
So let's talk a little bit about how how does that show up, right? So you can select all these different options or SDKs or APIs to make an implementation. And so just to give you an overview here, you have your Azure account. With your Azure account, you're able to get 50 Cosmos DB's account, right? But for our purposes, let's just say we're using one. So you now have your Cosmos DB account, and you can have as many databases as you want. You can have up to 50 databases. Now, and that's a soft limit. If you need to extend it, you can. Now, within one database, there's 2 concepts. There's a concept of a container and a concept of an item. So if you choose to go with the Cassandra model, well, then that's going to influence what kind of data you can use and how you can access it with the containers and the items. If you choose to use Gremlin, for example, which is another type of database, well, then you're going to be working with graphs. And so your items are going to be more focused on nodes and things like that. And so, again, depending on which model you choose, will affect the kind of container you're using, whether it be a collection, a table, or graph. And then whichever model you choose will then affect the actual item that you're using. So if you're using a table, then you're going to be talking about rows. You know, if you use a graph, then you're going to be talking about nodes. So Cosmos DB really provides a lot of flexibility when it comes to that. Getting started, I'll look this quickly because I know we're running short on time. But essentially, I'm actually logged into my Azure account here. It's really simple to actually launch a service. You literally go into Azure, you press add, and then it asks you several questions before you launch. And so I'm not, just to run you through, you choose the account name, it has to be globally unique. And Professor Lee, you asked about which model it has. Here's where you can see you can choose the core SQL, or you can choose it for MongoDB or Cassandra, or you can use a table, or you can use a graph. And so this is where you, as the application developer, database designer.
Maybe next time I can use the Azure Cosmos for our exercise lab.
Exactly. So I went ahead and actually created one already because it takes some time to launch it. But once you do, you can see here, I can just click and I can have access via an SDK or via this, I can do a command line interface, or I can work through Azure here. And this is really, and as you can see, it's super flexible, and you get all of this database management features with literally just clicks of buttons. So it's really powerful in that degree. So just going back here, you choose your service, your instance, your region, you choose the name, and then you launch. Some popular use cases are for artificial intelligence and machine learning, Internet of Things with telemetry, which is basically all of the data that the devices with IoT are sending that constantly to your database, e-commerce and retail. Some examples of Cosmos DB can be found with Microsoft Office, Skype, Active Directory, Xbox, the gaming platform, Microsoft Network, and then Mercedes-Benz, ExxonMobil, and Olympus. They all take advantage of the Cosmos DB platform. So that's just really a general overview of working with Azure and Cosmos DB.
That's it?
Yep.
Okay, thanks so much. Any questions? I think that I had a couple of times the selecting Cosmos DB before in this class, but I think the last few years they changed it, they improved the feature a lot. So I didn't know that they support multiple data models. So if that is straightforward and easy to use, I think I can really consider to use Azure. Because even the GCP and AWS, their database service is a service level inside they are using the relational databases separated, like the RDB and the AWS. And they have DynamoDB for NoSQL database, the key value assumption, they're different. But if this one is working, this is much better. Okay.
It's very flexible.
Yeah. Thank you. Any questions? From the student, you can unmute by yourself if you have any questions. Okay, so thanks so much. So please quit your sharing. Let me. Yes. Next one. So we did the tab, and Shiva, are you ready? Shiva here? I cannot find the name of Shiva. So then I have the file. So let me turn on the file for Shiva. And so let's back to here, and then Shiva, yes, I have. This is a presentation record. So let me change the sharing to the quick time. This is
this is Shiv Sankar. So
it's the same database.
Hadoop database is Azure Cosmos DB. So which is one of the NoSQL database. So let me just explain you the evolution of the Azure. My database. So basically, my database came to the form. It came in version by dealing with the problem of dealing the large database. So originally started to address the problems faced by the large-scale applications like Microsoft, and my database also created by the Microsoft company. So we just built from the ground up for the cloud, and it is used extensively inside the Microsoft. So let me just briefly explain you the Cosmos DB. Cosmos DB is just as a planet scale database, which is completely like you have different regions. It's like it's not like you can't use where the database is not computed. It's like we do have primary databases, and we is called as write database, and also the secondary database, which is like read database. So it's not like wherever the database is created, only the particular region users want to use. It's not like that. So the users from different regions can also have the access for that database. And this Cosmos DB do have the JSON format of database, and we do have multiple application programming interface, and it is a NoSQL language here. So the biggest problem to achieve a planet scale database is like consistency. Consistency is nothing but, so let me just explain to you. So we do have here United States where we do have my actual database, like it's said as a right database. And I just want to make sure the users of India do have the access of my database. So we're going to create some secondary database in India just like that, and we do give like synchronization between one data from United States to India. So during the process of synchronization, it's like after synchronization is done, every member can see the updated data easily. So it's like, but the thing is, during the synchronization, because it's like from the United States we are sending data to India, so it's gonna take like few minutes. In that particular minute, when the users from United States want to see the updated data, they can't able to see the updated data. And moreover, the users from India can also are not able to see the updated data. So we're going to take some time. So we do have in Cosmos DB there are like the strong bond session prefix eventually. This is going to help, like we can choose what type of consistency do you want, like whether do you want the performance based and you want the consistency based. So let me explain you the strong. The strong is nothing but if you want, you're going to send the data from United States to India. So the time, it's going to take like, let's say it's going to take like 30 minutes. So I'm personally in United States, and India, my friend is going to receive my data. So my friend gonna call me after 30 minutes that I have achieved your data. Then at that point of when I updated something during the synchronization, it's gonna take like 30 minutes to get my friend the updated data, so that the users from India can also able to see. So my thing is, after 30 minutes, after updating the data for everyone, then I'm gonna make it visible for everyone. So it's gonna be like for the same time of the users, like it's gonna be the same time where the users from United States can able to see the updated data, and at the same time, you're gonna from India can also the same. Just like the same thing as like the different thing is bounded. So if you want high consistency, you do have a delay in performance. So let's say the consistency is directly, inversely proportional to performance. Like, for the bounded, let's say the different, the bounded we do have the different lag period. So the bounded is like, we're gonna give some certain time period. It's like I'm gonna give everyone delay for like 2 hours. So that's gonna be the bounded one. The session one gonna to have like an average performance and average consistency. It's like the same as a bounded, but the different one. You do have like different types, like packets of data, and the prefix is like we're gonna send the data like A, B, C, D, the same way, the same pattern of the synchronization. The secondary data, the read data gonna be. So eventually, just like the same thing, we do have like lowest consistency and highest performance. So this is the best thing my Cosmos DB is. You can select what type of consistency you want, what type, because the thing is everyone we just want to decrease the latency provided in our application, because because whenever we update something, we always want to make sure our users are in perfect time to see all things. It's not like, okay, I mean, it's not like after 30 minutes my users can able to see, but it's like whenever you wanted to update the data at the same time, the users want, I mean, you want to make sure the users in every region will receive those data at the same time. So the multiply up, my simple database Cosmos Azure Cosmos, we do have multiple application programming interface. We do have different types of SQL, Mongo, Graph, Table, and Cassandra. These all different types of API you can choose while creating the database in Cosmos DB. So, let me just tell you the benefits of this database, like why I'm able to choose this one, like why I want to influence you to take this database, and why I want you to use this database. You have turnkey global distribution. Global distribution is like you can decide where you want to keep the head database and where you want to keep, which particular regions you want to make sure the user is going to see the database. That's the best thing. That's why it is called as a planet scale database, and it is always on, which is like it is always updated. It is always useful. It is always like in a constant manner. Like, and you do have elastic scalability of throughput, storage worldwide, and you do have low latency as LDR distribution because of the choosing of consistency level, so that you can reduce the latency. So you do have like precisely defined and multiple consistent choices, consecutive by default and enterprise programming. So yeah, thank you.
Okay, so we watched the video for the Shiba. So it's a good, I think, the matches between the Shiba and Peter. So we have the two proposal. So that's like the Azure Cosmos database. But interestingly, the Shiba talk about a lot the consistency and the consistency level. I think it's good to see how for example during the test 2. So he can select some example of the different consistency level. Then we try to see the example of use case of using such a the different level of the consistency with the example. Okay, so then the next speaker is the Subham. So is Subham here? Subham, yes, Subham is here. So do you want to present, or can I turn on your recorded video?
Anything is good for me.
So I think the presentation is much better for us. So can you share the screen and then present?
Just a second, Professor.
Yes. Then the next one is the site here, Kutala. So Sai is not here, so I'm going to turn on the. Let me turn on the site video, then Subhan can be next.
I'm ready.
Are you ready? Okay, go ahead. And let me start the sharing. You can take over the screen share. So Subham will present regarding to the Google Cloud of Firestore. It is, I think, the natural to select more and more the cloud-based NoSQL database. Okay, you can start.
So hello everyone. So today I'll be talking about Google Firestore. So what is Firestore? So Firestore is a cloud-based database. It's a NoSQL which is developed by Google. Okay, so the first part of Firestore is it is a part of Firebase. So Firebase is an application of Google, so which allows you to host application and storage of files and all other things. Okay, so Firestore is a DB by the Google. So another best part of Firestore is it can be used on multiple environments like mobile development, web development, server development, and also client-side development. being a part of Google, it is seamless. It is seamlessly integrated with all other applications of Google. So the question arises, why Firebase? So Firebase serverless development is the first advantage. So what is serverless development? In serverless development, the thing is client-side SDKs of Firestore handle all kind of transaction between your UI and the database. There is no need of server, that is any kind of backend languages like Node.js, Java, Python, and all other things. Second part is scaling. Scaling is done automatic depending on the load that the Firestore is handling. So there is no need of manual scaling. It is done automatically by Firestore. Offline usage. Once the connectivity with the Firestore is made, whether you have internet connection or not, the application will still run the same as it is at its run when you have an internet connection. Third is a robust query engine. So regarding the robust query engine, I'll explain later when we'll see the data model and the structure of how data is stored inside Firestore. Pricing, there are two levels. If you want Firestore on production level, then pricing is applicable, but for development purpose of student, we can use the free version of Firestore. Along with this, one more advantage is, as it is a Google NoSQL database, so Firebase can be hosted on any region worldwide. So there is no issue of if I have updated my server in United States, so India, people from Asia won't be able to connect to the Firestore. So it is done on from where the request comes. So next.
Can you clarify sometimes you are saying the Firebase, sometimes the Firestore. So what is the difference between the Firestore and the Firebase?
So Firebase is an entire application, okay, and Firestore is a DB which is supported by Firebase.
So Firebase is the developing platform, including the component and everything, and the Firestore is the part of Firebase. Database part. Okay, I see.
Okay. And also using Firebase, we can do hosting of the website or the application, and it is also free. And also Firebase supports three kind of databases. One is a storage in which you can store your video files, then comes to the PDF files and all that stuff. And there is a real-time database, but the thing of real-time database is it's generally a cache of what is stored in the Firestore.
So it means the Firebase or the Firestore does support the video data?
It supports, but you have to do some additional, what I can say, integration with the storage part of the Firebase.
Okay, not 100% clear. You can go ahead.
Okay, so the data model of Firestore. So Firestore is document-oriented NoSQL database. So in this, all the data is stored in the documents, and documents are stored in collections. One more part that is different of Firestore is a document can also have a set of collections. So the structure of Firestore actually can be said to be as a collection. Inside collection there is a document, and inside document, if required, we can add collections too. So next, how data is stored in the document. So data is stored inside the document in the form of key value pair. So the value is what we want to enter, and the key is auto-generated by Firestore. It can be created manually using our client side or the server side, but there is no need as Firestore themselves provide with a key value. So coming back to why the robust query engine is required. It is required because of this nesting of documents inside the Firestore. So Firestore gives you simplified queries to access each and every document and the collection if stored inside the document. So there is no much to be written, and a simplified query is provided by Firebase, and that does not impact how much it is nested. no, it doesn't take more time to get back with the output. Then installation. As Firestore is cloud-based, there is no installation required. You can just go to the Firebase Console and you will get all the necessary information for the connection to the application. So I can show you how it is done. I just need a second.
So Firestore is the kind of service in the data service.
Yes.
Okay. And also it's a part of the Firebase, right? So Firebase is kind of the entire the platform to develop the mobile, the application, and so on, right?
Yes. So this is the Firebase console. In this.
Please share the screen.
Oh, sorry, I'm not sharing my screen.
Yeah, you are sharing right now the PPT file, so you can change the screen share to the yes.
Okay. So this is the Firebase console. I just what I did is just click on a new project. So I'm creating a new project named test. So just continue, and then these are the analytics and available that is done by Google, and it's free, so there is no need for user. So select an account, so default account for Firebase.
So you can develop the iOS the project with the
Yes,
Firebase.
any platform is okay.
Any platform? Okay.
Yeah. So I'll show you how to connect it to the iOS also. So there are options that are mentioned on the console. Okay, so this is a sample project. So as you can see, we have an option of iOS, Android, and web development. So the thing is, this is Cloud Firestore. Authentication is provided by Firebase, and we have to do nothing. We have to follow a few steps, and that's it with the authentication. So I was talking about videos and PDF files. So this is a storage which is provided by Firebase. In this we can store all kind of videos and PDFs and can be accessed using the Cloud Firestore. So inside Cloud Firestore, we can create a database.
You don't have to show everything right now, so you don't have to. That should be done in the next page. Okay?
Okay.
Yeah.
Okay. So that's how we need to do the connection with the Firestore. So next is data manipulation. So it has very simplified queries for performing all kind of cloud operations. That is insertion, deletion, update. Is very simple, and it is all can be done quickly. There is no response and request. Much time is taken by the Firestore. And it has a great support for nested queries, as I explained before. Then also one more feature of Firestore is bulk insertion and bulk deletion. So you can get all the IDs from the Firestore and just hit with the bulk deletion. And also you can have a for loop, and you can take all the data in an object and just hit the object and send the object to the Firestore. It will store all the data in the form of collections and document. There is no need to go on Firebase console and enter your data. Then update can be, so the best part is, as the key is generated by Firestore, update is very easy. So just by getting the key, nothing else is to be done. Just provide the key and the new values, it will get overlapped on the existing one. And also, if something wrong goes on the Firebase after you fire an update query or something, then Firestore has inbuilt data validation rules. If something goes wrong, it will give you an error message that at this point, when you executed this, we got an issue, and that's how the integrity of data is maintained.
Okay, so finalize. Oh, okay. Last slide.
Thank you.
Okay, thanks so much. And my suggestion is when you are doing the next page, the test 2, so you can select one of the project that can show the very well for the characteristic of the Firestore. Okay, so you
Sure.
can select one of the project, but that show the really the benefit of the Firestore. Then it will be next project.
Sure. Sure.
Okay.
Sure.
Any other question? So from the student? Okay, if not, let me change it, the screenshot to the list. So the next one is the sixth presentation by the Saitya. Saitya, not in the class, so I have the file over here. So let me start this and share the screen to this and play.
Good evening, Professor. Good evening, everyone. I'm Satya Shakutala. I've chosen Couchbase Server NoSQL database. Coming to the brief overview of Couchbase Server. The Couchbase Server is a document-based, it's a distributed and a scalable NoSQL database. The most importantly, it is an open source. The Couchbase Server is basically a merger of Membase and the CouchDB, which is also called as Couch1. The memcached means it caches the data and the objects in the memory that reduces the interaction with the database service. So Membase is based on the memcache based. So CouchDB is also a document based, a single node. This Couchbase server also supports the ACID transactions, ACID compliant transactions. It is very fast, simple, and has fault tolerant design. This Couchbase server is available for all the operating systems, Linux, Ubuntu, Windows, Mac OS. It also provides the software development kits, which is called SDKs, for .NET, Java, Python, Ruby, Scala, all these languages. So it uses non-formal first, the query language, which is N1QL, pronounced as Nickel query language for the queries. This replicates the data in the clusters, so that's how it is distributed. So in designing the architecture of the Couchbase server, the three core design principles are followed. One is memory and network center architecture. So if you want to move the data from one cluster to another cluster, that is one memory to another memory, that will be taken care by the database change protocol, which is called DCP. In the Couchbase server, the workload is isolated by the multi-dimensional scaling, MDS. For example, if you have querying, searching of the text, so all these tasks are separately isolated from each other. If we have any backend synchronous and asynchronous process going on in the Couchbase server, that will not affect the read and the write operations in the front end. So coming to the data is stored in the form of documents. If it is a JSON document, if it is not a JSON document, it will be stored as binary large object, which is called BLO. So in the documents that are inserted into the Couchbase server, so will be stored in the buckets. So each container which stores the documents is called bucket in the Couchbase server. These buckets are distributed among the clusters. So this is the thing that is showing the app side and the server side. The data which we inserted, that is the documents which inserted into the Couchbase server, can be accessed by the following access methods. So in the first one, key value access method, so each document will have a document ID through which we can access the document very quickly. So in the second, the query and analytics method, as I said earlier, we are using the N1QL query language to drive the database. So that will be discussed later, the queries now. In the full text search, so if the user wants to search certain text in the document, that can be done by using the text analyzers with the tokenization. And it also has the language awareness. The documents must be in English. So which returns the document IDs. For example, if you are giving some text, if that text is in some document, that document ID will be returned. Eventing is actually based on the action, the event will be performed. This will be like the JavaScript functions in the backend and the database servers based on certain types. So in it also has the indexing indexing and the secondary indexes called views. The schema will be optional in the Couchbase server. So coming to the NoSQL query language, Nickel query language, it is the implementation of SQL++ standard. As I said, this is SQL for the documents, which supports the standard selects from where these are now classes from the SQL, the traditional relational database management system. So in addition to that, there are the nest and the nest classes. For example, the nest class is used to extract an individual item from the JSON array. The nest will be quite opposite to that. And there is also a missing Boolean keyword. For example, if there is any creation date of the document or name of the document is missing, we can find it out using this missing Boolean keyword in the where class. As the indexing support, you can use the index, array index, and the query will be very consistent. So coming to the characteristics of the Couchbase server, it is highly available. There is no need to take it down offline for maintenance or for any software updates. So for every bucket in the Couchbase server, there will be up to at most 3 replicas can be defined. So the cluster manager actually detects the node failures if there are any failures, and it initializes the rebalance process without any manual intervention. This will be done automatically. So we can also replicate our data across the different data centers geographically. This is also available in the Couchbase server. So coming to the security, so all admins, users, and applications must authenticate to gain access to the database. So this Couchbase uses role-based access control authorization. Depending upon the role assigned to the user, they can access the data, and the number of actions will be limited based on the role. So this can be, these actions and all can be tracked by the admin, that is called alting. And this Couchbase server encrypts the data while transferring between the nodes. This Couchbase Lite is actually used for the mobile. This is a lighter version. So the sync gateway is actually keeps in the synchronization with the Couchbase server. This Couchbase provides the end-to-end security. Thank you so much. If you have any queries, you can email. Thank you.
No email is given. So my comment on the Couchbase server is I'd like to see some examples of using the Nico N1 QRAP that shows the characteristic of the Couchbase databases. So in the next page, that's my suggestion. And then the next one. So back to this. So we did the side tab. So next one is the Louis. Is the Louis here? Let's see no. Oh yes, no. So okay, then I'm going to the copy and paste this one to the. Hold on.
Hi everyone, my database project is Apache from.
Oops, not it. Yeah, I'm going to share the screen. And then.
In 2006,
Okay.
published Untitled Chapter.
This is the Allegro graph. by the
This
link.
table describes the design on which Humlo is based on. Humlo is an open source distributed key value store designed to organize trillions of data and enable fast recovery. Humlo was created in 2008 by the National Security Agency. Humlo later becomes an open source project supported by the Apache Software Foundation in 2011. Beyond the original designs of Humlo Big Table, Humlo has a few additional features that makes it special for certain applications. The first major feature is Serverless access control. Humlo supports client security models called visibility to each user to protect them from unauthorized access. The second major feature is server-side programming. There's a programming mechanism called iterators that alter a key value pair at various points in the data management process. The third major feature is design to scale. Humlo support multiple volumes with features like automatic failure recovery, dynamic, and unlimited column. Humlo is written in the popular Java programming language and is built on top of Kubernetes and Zookeeper. Humlo is also compatible with other open source.
Sorry,
Multiple
this presentation is for the Apache Accumular by the Louis.
data projects such as Apache Hive, Pig, and Spark. Now let's look at the data model. At the most basic level, Humlo stores key value pair. These key value pair put together into table. Beyond storing them, Humlo stores key value pair by key. This allows value associated with a particular key to be found very quickly by performing a binary search. Value in Humlo consists of an array of bytes, and there's no restriction in data storage. Key in Humlo consists of three components: a raw ID, a column, and a timestamp. These components give application designers some control over how data is handled. If you are familiar with table in relational database or spreadsheet, the raw and column concept will be familiar. A set of key value pair with the same raw ID are considered in one logical row. Each row can have multiple values, each associated with a column. Raw ID and column consists of byte array. And over time, we may choose to store a new version of a value associated with a particular row and column. Timestamp component allows us to store new versions of a value. We may choose to pay attention to only the newest version of a column, of a row column, or we may choose to retrieve multiple versions if they exist. Timestamps are interpreted as Java long integer and are sorted in descending order. A Humlo sorts key first by the raw ID, then by the column, and finally by the timestamp. If we look a bit closer at the Humlo data model, we find that the column component itself is split into three components. In the original big table by Google, the column consists of two components: column family, column file. And the designer for Humlo added a third called column visibility. Column family is used to grouping columns that are common in order for faster access. Both column family and column file consist of bytes and is sorted first by the family, then by column file. Column visibility component, which is added for Humlo, can contain a secure label that describes what authorization tokens are required to read this particular key value pair. And this is the complete Humlo data model. To conclude, Apache Humlo is an exciting key value store database to learn, and is based on the Google Big Table. According to the DB Engine ranking in 2018, Humlo is the third most popular database behind Hadoop and Cassandra. Humlo is highly scalable, secure, and robust in data storage and retrieval. Humlo is ideal for developers to build secure real-time applications, such as application for Internet of Things, application for displaying graphical data, or real-time metric or analytic applications. That is all for my presentation. Thank you.
Okay, thank you. And I think so in the last slide, says the accumulator is the top, the database. I cannot believe it. I'd like to see the reference or the source of that because the accumulator is way behind the HBase in the market, and also recently I don't see any the big step of the accumulator in the Apache Foundation. So, but I'd like to see something, the example or use case of the accumulator working with the other Hadoop ecosystem because it's anyway based on it's a family of the Hadoop. So may just like the HBase, it may be comparable with the other the Hadoop the ecosystem. Okay. Then next, so let me share our. So we did. Servants, right? So and next, actually the next one, the 8 is the allelograph. Okay, so I got confused. So, Umesh, are you ready?
Yes, Professor.
So you can take over the screen share, then you can start when you're ready.
Hi everybody, this is Romesh. I will be presenting Electrograph database. Electrograph is a high-performance graph database. It uses the memory efficiently by enabling scaling, leading to better performance. It is a closed-source triple store. That means it is designed to store RDF triples, standard format for linked data. Electrograph was developed by France Incorporated and was made available by the end of 2004. As we all can see, it has client interfaces in Python, Java, C#, Common enclosure. It is available on macOS, Linux, and Windows platforms as well. My motivation in choosing Electrograph is that even though it is a closed source triple store, it is currently being used in many open source projects, defense projects, and commercial projects. Social network analysis mainly requires the implementation of graph algorithms. Using semantic graph technologies process conceptual data and contextual intelligence data. For many applications, graph database can be faster, flexible, and more understandable. Coming on to the characteristics. Electrograph is very easy to understand as it is done through simple graphs. And my point on saying it is better than RDBMS, even though it uses graph, is that we can add new predicates without changing any schema. One-to-many and many-to-many relations are modeled directly instead using intermediate tables. In query languages like Sparkle, the graph relations to search for one expressed directly rather than in terms of join as in SQL. And in RDF, the RDF stands for Resource Description Framework. In RDF format, data is represented as assertions, where assertion is equal to subject plus predicate plus object plus graph plus ID, where the subject refers to the start of the node, which is the beginning of the segment. Predicate is the name of the node. Object would be the value. And even though by using these three components, we would require one more to show the contextual information that is by using graph. Even though it is not triple store, it looks like it is a quad. It is a non-RDF, but yet it is helpful in adding many components. The logical structure of an electrograph consists of assertions, indices, strings, free text indices, and deleted records. And as we all know, like every other database, even this proves ACID properties like atomicity, isolation, durability, and consistency. The installation is pretty simple. We could download the server and meet it to keep the electric drive running. Server installation can be done in 20 minutes. From the RPM that is required for the systems to run the technologies. We could connect the server and start running. My conclusion is that even though it is a triple throat graph database used in many it is being used in many popular open source projects. It is a high performance database as it is well with memory utilization, and it is a multi-model that it uses both graph and document, and social network analysis has better representation of the graphs and graph databases work out best.
Is there any use case of using the Allegro graph for the social network? No? Yes, the reason why I'm asking such a question is if you cannot find the real use cases, so I think the next page is that even though they are saying they support the multi-model, so like the document, but definitely you are going to use the graph data, such as the social network, Facebook data, or some other. I'd like to see such an example of using the Allegro graph for the social network model. Hello?
Yes, Professor.
Yeah. So in your next page, I'd like to see some real example of the Allegro graph for the graph data, such as the social network model.
I will, yeah.
Okay.
I will implement in the next phase.
Yeah.
Thank you.
Okay, thank you. Okay, so then let me change it to this. Then the next presentation is by this one. This one, are you here? Let me check. This one is not. Oh yeah, here. So okay, so you can take over the screen share, then start when you are ready. Almost looks like yes. I can see your screen. You can start.
Can you see my screen?
Yes, we can see your screen.
Yes, we can. Yeah, thank you.
Thank you so much. So, my name is Rizwan, and I have selected the So, let me give you a short introduction. So, this is a document storing database. That means all the information and data that is document. And the data inside the document will be in the JSON format. So it is a multi-platform database that macOS, Linux system, and therefore some very Java, So it is highly available. When you have the available distributed database, which is a very major issue on some people got into the platform, but they have to use some. They try to use some algorithms and they try to design it in a way they can make it not 100% available, but the most effective. Okay, so let me tell you some reasons why RavenDB is a better document database. So first of all, it is very fast and can do up to detail. And then it is a fully transactional, which is compatible. That means
it can do transactions across all the nodes in a cluster. How it does is it makes the log and the transaction is suspected and related to all the nodes and will be written on the disk, otherwise it will roll back the transaction and let you know about failures. So, and as I tell you, it's a JSON format, the document, the data in the document, JSON format, and the data model is the most specific for the data. It depends on the user how you want to query the data later. So you will model your data as per your requirement. So sometimes you have to embed the data into a same document, sometimes you have to refer other documents in one document. So it depends how you want to use. You will embed the data in the same documents. It will be faster because you can retrieve all the information about the document. And query, but you will be referencing. You will have to make the queries. And there is a regulatory language, they call it RQL. It is just a query language. RQL is very similar to SQL. So if somebody has SQL, and they have some predefined keywords. And the next, you can also use RiverDB to migrate your data from SQL to RiverDB from SQL. They have tools for it, and you can extract the data and it will transform it into document, and then it will this. The next is the feature is concurrent notifications, which says if two modifications come at the same time, it will ask you which one to use. So you have to decide it manually to let you know that you can at the same time and decide which one you like to use. And then the concurrent read and write, that means the multiple multi-master, that means all these slaves and all the nodes are like masters and slaves to each other. So that will make it make it more consistent and available in the database. The next is this is about, these are some major important points that this is why better than some other documents. So now I will let you know about the installation. The installation is very simple. You just go to the website, download the server, and you can just get it. Since I have installed here, I will show you a quick how it looks like. Let's just go the So this is how it looks like when you install and run it. So I have a database created here. That's my test database. I have a document stored in it. You see, and the documents inside looks like a JSON. So if you are familiar with JSON, you can manipulate it and that's all from. You have a question.
Okay, so I just unmuted. Thanks so much. So LabelDB kind of one of the oldest NoSQL database, focusing on such a document, the data model. So I think we have another student who selected the LabelDB also. When you implement the next time, I have seen the many students who selected the LabelDB for the research. So think about the implementation. So that shows the main characteristic or the special characteristic feature of the LabelDB, like for example, for example, the JSON file as a data, then you can insert the number of JSON file, then would like to access the JSON format. Then you do not mention about the API level. The LabelDB definitely has such an API. So you are going to select the programming language and connect and implement the use case of the label DB. Okay?
Sure.
Yeah. Any questions from the student? Any questions? Okay, thanks so much. This one? You didn't submit, did you submit? So I have it. Okay, thank you, no problem. I'm confused. And next one, let's select. So next one is another Laban DB by the Sharma. Are you ready?
Yes, sir.
Okay, so you can start. Take over the screen share, then start when you are ready. Please try to finish within 5 minutes. We are running out of time.
Good evening, Professor, and good evening, friends. My name is Shreyas, and the database which I choose is the RavenDB. So we know that NoSQL database are quickly becoming a major part of the database landscape today, and they are providing a real game changer in the market right now. There are numerous benefits, including the lower cost, open source availability, and easier scalability, which makes NoSQL an appealing option for anyone thinking of integrate with big data. Here are the outlines. What is RavenDB? As my friend mentioned earlier, RavenDB is an open source document database written in .NET. RavenDB is mostly focused in rapidly and efficiently creating high performance and low latency applications. Here is the data is stored in a schema-based JSON and can be efficiently retrieved by RavenDB.NET API or the RESTful API over HTTP using link. It's built on the top of the Luciancy. Luciancy is just a full text search library in Java, which makes it easy to add search functionality to an applications or websites. As is popular in the NoSQL database, RavenDB is designed for web scale and support out-of-box replications and the sharings.
What does that mean, the web scale?
So it's created for the web applications above.
Web application, okay.
Yeah. So why RavenDB? RavenDB is, first of all, it's easy to use. It is extremely easy and simple to use either by developer or a non-technical people. It also works on multiple platforms, it can install on multiple platforms like Linux, Windows, Mac, Docker, and even on the Raspberry Pi. It has multiple clients, can be accessed by using major programming languages in the market, including C#, Java, Node, Python, Ruby, and Go. It's simple NoSQL query means it has a powerful ways to do querying, including geospatial, nested, text, and map-reduce operations. It has index supporting also, means index in the RavenDB are one of the strongest point. Being a NoSQL database, it has intelligent solution to avoid multiple requests to the database by merging multiple tables. So some of the characteristics are as I
Is it only running on the memory?
So it's an in-memory database that one can use means persist the data from one application or a memory app.
Okay, go ahead.
And means here are some of the characteristics. Means as I mentioned, every document must have an ID. It is a schema-based, and the database does not enforce any schema. As I already mentioned, the documents are also stored as in the JSON format, and the readability is also very fast. And I also mentioned about the Luciancy, means it has full power of Luciancy, means full text research, auto-suggested, face data, and research more like that. So my friend already shows how to install it on the Windows. So basically, we have to open the PowerShell, and we have to run this executable. We have to execute run.ps1 once we execute the PS1, this screens get pop up, which is on your screen. After that, for the setup, we have to execute the setup service.ps1. Later on, once we set up, we can get the configuration new instance screen, which is on the left side, topmost left corner. There we have to select an unsecure version. After that, the second screen will open the HTTP and TCP IP portal. It just we don't have to do anything there. Just we have to click on the next button, and on the bottom left, as my friend shows, it would appear it would appear the studios, DB Studio. And on the right hand bottom side, I created the database test sample. As my friend showed how to create it, it's stored in and there is another option also to install database DBs through the Docker. I didn't mention in the PowerPoint slide, but I mentioned it in our Word document. So on the conclusion means, as I mentioned, the RavenDB is an impressive document-oriented database built on specially on .NET or the Windows platform. It automatically generates the ID for the record, and it doesn't have any option to get. There is one negative point, means it doesn't have one of the negative points, that it doesn't have any option to test reading or replications and authenticate access without the purchasing the license. Although it's open source, they have the they have other features which we have to purchase if we want to use. Overall, the performance great, and my personal recommendation and suggestion is that even if it's nicely to have an option for the basic learning stuff. On top of that, means it has also means as my friend mentioned, the migration is also possible from RavenDB to MySQL and vice versa. Other stuff is the security. It has excellent options like certification and encryption, that the data is well secured. Here are the sources from which I referred. Thank you.
Okay, so is it available only on the Windows platform, or does it support other platforms?
So, no, it also supports other platforms, but just for the example purpose, I just put how to download on Windows platform, because my laptop is on Windows. So that's why I put the screenshot on PowerPoint slides.
Okay. Okay, so any other questions from students? Okay, so great, thank you. And the next one. So we did the Sharma. And the next, Brian, are you ready?
Professor, yeah, I'm ready.
Yeah, okay. So let me start the screen share. So you can take over the screen share and start when you are ready. Yes, great.
Good evening, everyone. My name is Brian, and the selected NoSQL database that I chose was React KV. KV standing for key value. So
Can I pronounce the React database? Go ahead.
So basically, the introduction of what React consists of is basically it's a distributed NoSQL database, and it's basically designed to help deliver data availability across many servers. It's a consistent system that allows the user to read data and remain available throughout most scenarios, even if they fail. It's a key thing to know that it's basically made for its resiliency, which is an important aspect of the NoSQL database. And we also have the reliability from having a lot of scalability in many different environments. So the motivation, like I've stated before, for using this database, NoSQL database, is that basically if the user wants to avoid having data loss, it's important to use this NoSQL database. since it's highly optimized for its resiliency. And the way that's done basically is that the data is replicated into 3 nodes in a cluster. That way the user has, we can ensure that the data of the user can be available. Like I stated in the previous slide, so several copies of that data stored within the user's application, and the importance of having this key aspect of this NoSQL database that you increase the user's trust and experience, and again, you avoid downfall in revenue, and you avoid critical data loss. Other 2 key aspects of React KB is that it's highly scalable. You can handle a large number of keys, a million of users, and data points and data points and petabytes of storage. Data can be redistributed as nodes in order to balance data across the system. And you can scale up and down accordingly in order to reduce the cost of the scale. It's very simple to use. The user can easily add and remove those nodes in the cluster depending on the usage or how much capacity of the data the user is using. It's less expensive to operate than most NoSQL databases since it requires less CPU. And like I said, also users can easily configure the capacity by adding and removing where needed. So the data model, basically the values are stored as binaries. Binaries are either JSON, text file, images, or XML documents. The search is considered as one of the querying options within the database, NoSQL database, and it's usually the default choice. And for the best interaction with the data, it's best to provide a structured bucket and key names for the objects. I'll explain that a little bit more. But overall, React is best for like JSON files, log files, and sensor data, HTML files, and other objects less than 1 megabyte. So like I previously mentioned before, you have 3 main querying options when it comes to mining data. React Search being a component of integration that allows index and querying. You have also secondary indexing. It's an option where developers have the capability to mount objects with 1 or more query values. And thirdly, as we all know, MapReduce. This option also allows developers to just basically filter documents by tagging. And it's key to know that also MapReduce is usually not the best time to use it is when you actually know the object that you want to use and look for within your data. Otherwise, React Search is usually the primary option. Since it's straightforward, you use within all the storage backends within React. Installation-wise, it's pretty simple. For macOS, you could use Homebrew, and you can do it simply through the terminal, through brew install. And also you can install it via source, simply using those commands right there.
So 2.2 is the current version of React? 2.2?
2.2. So based off the documentation, that's the latest that I've seen. Unless it's not good, I don't know if the website has been updated quite recently, but documentation states this is the
Okay. Go ahead.
And in order to state, to realize that if you install this correctly, is to run these certain commands called React start, aim, and admin test. And if you have a node up and running, you can see that output represented at the bottom. And lastly, I give an example basically of how the data can be manipulated using the search option I've mentioned in the previous slide. So like my primary programming language would be Python. you could use other programming languages like Java, Ruby, C#, whatever for Python. So first, what you would have to do is you would have to create an index. For example, you would create that index. In this case, it would be famous. And then on top of that, you would have to associate that index to a bucket type. And in this case, you can consider the bucket type to be props or like features or values. So an example of the index and values would be, for example, animals, and then the bucket type being cats. And then you can have an example of you querying that data. Basically, in this example, you have all the documents in which the name S begins with line. So basically what it does is it goes in and looks at the index, and then it gets every single content that provides and that's located in the line, and you would print out the results. And these will be all the attributes of the values. So again, like I mentioned before, like React KV is basically known for its resiliency. Since the application is seeks to have the user's data at all time, even if it fails, even if a node fails. And overall, it's basically a node is just responsible for storing all the key values within the cluster. Nodes, each of the nodes within that inside the cluster are all responsible for the same thing. One node does not have more responsibility than the other. And basically, a cluster is just a group of nodes, just having constant communication just in case a node fails or not. And when that does happen, when a node is detected that it's down, it'll get the responsibility of the other two nodes just to back up the data while the service tends to be back in the data time. And basically, that's pretty much it. That's my references. Thank you.
Okay, thanks so much. And the most of the NoSQL database, which are based on the key value, they focus on the performance. That's the first issue. Because of that, it's simple and scalable. So in your use case for the next page, you can think about the way of showing such a characteristic in your implementation.
Okay.
And also the Brian's writing up is one of the best ones. So definitely I will give the extra point. Thanks so much.
Thank you.
And next, so we have two more. So next one is the Pranager. Are you there?
Yeah, yes.
Okay, so you can share your screen. Then start when you are ready. So the Pranager will present OMDB.
I think, can everyone see my screen?
Yes. Yes, very nice.
Okay, good evening everyone and professor. So my name is Pranjal Sanjay Varade and I have selected OrientDB. Let's get started. So OrientDB is basically an open source NoSQL database which is written in the Java. It has a multi-model data set, so it supports the document model, key value model, graph model and object model. The relationship in the models are connected by the graph database model. Even in the document model, internally the relationships are present in the graph model. And also it supports a schemaless, schemaful or mixed schema models. So what is schemaless? So in the schemaless model, we won't have the rigid schema such as rigid relation between the data types and relation between the data. And schemaful, as we already know, there is a rigid relationship between the data models and the mix also. Professor, can you give me just 1 minute? I think.
Any problem?
Yeah, now it's working.
Okay.
So some of the characteristics of OrientDB is that it is a
I mean, so it's a NoSQL database that mixes the strength of graphs and ability of document to form a scalable and high overall performance database. And the characteristics of the OrientDB is speed. So OrientDB is very fast. As I mentioned, internally it uses the graph to show the relationship between the models. So read and write operations are both done quickly, and it transfers the graph very quickly, and it stores a huge data set. Zero configuration. So OrientDB has the multi-master architecture, but even after having the multi-master architecture, we don't need any extra configuration, and it is suitable for the cloud. Low TCO. So what is TCO stands for TCO stands for the total cost of ownership. It is the community edition of OrientDB is free of cost, and it comes with the Apache 2 open source license. So it eliminates the need of multiple products and multiple licenses.
So OrientDB is a part of Apache Foundation project?
Sorry. I think there is, sorry Professor, there is issue with the, okay. Sorry?
So the OrientDB is a part of the Apache Foundation project?
Yes.
Okay. Is still the ongoing the project, or is it closed?
No, it's ongoing.
Okay, go ahead.
Flexibility. So as we know, as the requirement of the database changes, it costs a lot to change the whole database schema and everything. But as I mentioned earlier, it supports the schema-less, schema-full and the mixed schema model. So it's very flexible. Even there are any changes in the database, we have to. So if we have to do any changes, it is easy and very flexible. Next is the data model. So as I mentioned, it is a multi-model NoSQL database management system. So first data model is document model. So in the document model, there are the collection of keys and pairs, or we can say that it is the collection of field and property. So in the document model, we have the special concept called as a link, which shows the relation between the different documents. And what is the speciality of link? Because when we fetch the one document, all links which are connected to those documents get resolved. And this is the major difference between the other document DB such as MongoDB and CouchDB. Next is the graph model. Graph model is a network like a structure which is like interconnecting vertices and edges. And graph model, as I mentioned, it has the multiple vertices and edges, and it follows the concept of graph. Next is the key value model. So it is the simplest among all of three. It has the key and the value. The values can be a simple data type or array or an object. And next is the object model. Object model is inherited by the object-oriented program, and it supports the inheritance between different types. Different types means subtypes, extend the supertypes, and etc. And it also supports the polynomial. To installation the server, there is a brief manual on the OrientDB website where you can go and you can have a step-by-step installation process and everything. So anyone who is interested can go and check out the OrientDB documentation. Conclusion. So OrientDB is one of the dataset which has the multi-model dataset, and which is the open source database. As I mentioned, it has 4 different data models: document model, key value model, graph model, and object model, and it has a high speed and flexibility. Thank you.
Okay, thanks so much. I think that even though the OrientDB support all these 4 data models, so I think that in your next step, you are going to select one of them for your data, then focusing on to show what is the benefit of using OrientDB in such an application.
Yes.
Okay?
Thank you.
So next, the last one. So, John, are you ready? Oh, let me check whether he He provide the recorded video. I'm going to turn on the video. Okay, so then share the time player, and this is a 4 minute.
Hello everyone, my name is Fishy John, and the database that I choose is CoachDB. Let me briefly introduce it. CoachDB is an open source database developed by Apache Software Foundation. The focus is on the ease of use. It's a NoSQL document store database. It uses JSON to store data, JavaScript as its query language to transport the documents, HTTP protocol for API to access the documents. CoachDB has an HTTP-based REST API, which helps to communicate with the database easily, and the simple structure of HTTP resources and methods, such as get, put, delete, are easy to understand and use. As we store data in the flexible document-based structure, there is no need to worry about the structure of the data. Users are provided with powerful data mapping, which allows querying, combining, and filtering the information. CoachDB provides easy-to-use replication, using which you can copy, share the data between databases and machines. Database is the outermost data structure and container in CoachDB. Each database is a collection of independent documents. Each document maintains its own data and a self-contained schema. Document metadata contains relation information, which makes it possible to merge the differences occurred while the databases were disconnected. CoachDB implements multi-version concurrency control to avoid the need to lock the database field during writing. A CoachDB document is a JSON object that consists of named fields. Fields values may be strings, name, numbers, case, or even order base. CoachDB integrates a view model using JavaScript for description. Views are built dynamically and do not affect the underlying documents. You can have as many different view representations of the same data as you like. With CoachDB, no schema is required, so new document types with new meaning can be safely added alongside the old. CoachDB is a peer-based distributed database system. Any number of CoachDB hosts, such as servers and offline clients, can have independent copies of the same database, where applications have full database integrity, such as query, add, edit, and delete. When backline or on a schedule, database changes can be replicated bi-directionally. And here are screenshots of CoachDB management interface. That's all, thank you.
Okay, so we complete the 13, the presentation, and the total, I think, the 10 different NoSQL databases. So you may get the second experience at least to know about more NoSQL databases. The next step is you are going to let me change the view like that. This is much better. So next step is you are going to implement. First install your database or the setup. If you are using the cloud-based NoSQL database, you need to set up the create your NoSQL database on your cloud. Otherwise, you can install your NoSQL database. Then what you're gonna do is you are going to implement one of the use cases. So the one possible way is you can create the application, web application. The backend part is your selected NoSQL database. The front end part is your any web application, or you can create the Android application or iOS application, or sometimes you can use your selected NoSQL database for data analysis. Like for example, some of the databases support such as the data analysis, or even though you can use the map reduced application. So you can select the suggested or the recommended some use cases for during the presentation. But even though I do not recommend, but you can select one or two best the use cases, then implement it. It's kind of the practice to use the NoSQL database. To do that, sometimes that is one of the reasons I ask you to show how to install brief manual to install your database. So sometimes your selected database does not support the free version. So first, you need to check whether you are able to install the selected NoSQL database on your laptop or computer or even the cloud. Then create the data model, then download, collect the data, and install the update or the upload such a data in your database. Then implement one of the use cases. Okay, so that's what you're gonna do. Then the last phase will be the demonstration with your presentation. So mostly demonstration based on your the use case. Then we will see how we can use. Then later, if you get a job and in your company, so if your company asks you to use the model, the NoSQL database, you can refer one of the database, NoSQL database that we used in this class later. Okay, that's my overall plan for the rest of the semester. Okay, so any question regarding to the phase 2 presentation? Okay, so based on I think I almost graded, so the grade for the phase 2 will be updated by the end of this weekend. Also, one more thing. Those who are attending this class today, also those who are watching this video, please send a Canvas message by the end of this weekend, including your comment on one of the presentation, not yours. So you watching the presentation, you can select one of the presentation, most impressive one. So select the one, the database, then your comment or your feeling or your just one paragraph. Then I'd like to give the extra point. Those who are sending your note or the comment by the end of this weekend. Okay? So one more time, if you send a note, your comment, you can select the one of the presentation, then you can comment, the one paragraph comment, then send the Canvas message to me. Okay, I'm not going to open any submission site, just send a Canvas message by the end of this weekend. Then I'd like to give the extra point, those who are sending the comment to me. Okay, everybody understand the extra point after this? Okay, so you don't have to submit, but just send a Canvas message. So those who are attending this class, or those who are watching the recorded video, I'd like to give the extra point. Okay. And today's topic is for the relational database. I already explained and introduced. Even you learned the relational database a lot, so I don't have to spend a lot of time. Instead, I'd like to the point out some important the characteristic or the feature of the relational database to understand the NoSQL database today. Let me share the screen. It's too many. Okay, so I think that this one. And the view is a full. Okay, so let me quickly check the, can we get, oh yeah. Okay, so let's have the 5-minute break. Okay, let's have the, even I need to go to the bathroom. So that's good suggestion. So let's have the quick break. We are going to resume from the 8 o'clock Eastern time. Okay. The start today's lecture, even though we have only the 25 minutes. So I'm going to try my best to point out the feature of relational database from NoSQL database point of view. So let me share the screen. This one. Okay, so this is, even though the title is a summary of relational database management system, so if you take a look at the number of slides of the lecture note is 100, almost 200. It's not like the summary. So I try to put as much information as possible for those who didn't take the relational database or the advanced database design course. So if you are not familiar with the relational database management system or the relational model, it is good time to go over the concept of the relational database model. Otherwise, if you already took the advanced database design or the database design course before, so this is good time to review and remind what you learned from the courses. However, the main reason why I'm introducing the relational database management system again is to understand the NoSQL database concept. It is true, the NoSQL database is coming from the approach of to address the problem of the relational database the model. So I already introduced a lot such a concept of the relational database and also the shortcoming of the relational database. So then I quickly go over. So later when you study, when you review the RDB, then you will easily understand such a concept. Okay. First, we need to understand what is a really database is. So let me briefly. So actually, there's no computer science or the computer program that does not use the data. So we have always the data. By the way, where is such a data when we process, when we manage such a data? Actually, data in our computer is in the primary storage. That is the memory. So memory is the primary storage where the data are stored. Eventually, this data will be accessed by the processor, CPU. So CPU processes the data. So think about your program language. Program language, you define the data, like the global variable, local variable, or array, or list, a dictionary, whatever, object. It says data. So data, whenever you create your variable, whenever you instantiate the object, this will be created on somewhere in your memory. So actually, our database is on the memory. So our data is in the memory. It's a memory-based data management. However, as you know, everyone knows the memory has the limitation. Even though it's a primary storage and it's fast, but it's not permanent storage. So it's a volatile. Without power, we lose the data. Also, second problem is limited the size. So we cannot put all the data still. We cannot put 1 terabyte or the 1 petabyte size data into the memory. Even though we are using the memory-based database in NoSQL database, such a memory-based NoSQL database is for cache purpose. It's not the main storage purpose. So because of that, people we have more and more data, when we have the bigger and bigger data, so like it's almost 50 years ago, 60 years ago, 50 years ago. So at that time, in 1970, 1980, they encountered problem of size of data. Okay, their size is like the 100 megabyte or the less than 100 megabyte. It's a big data, but still they had a problem. They tried to address such a problem. So idea is first put down the such a data into the secondary storage. It's the permanent storage or persistent storage, like the file system. However, the problem when we put down such a data into the file system, permanent storage or hard disk drive, the problem is the speed. The speeds go down. So that is the main problem. So they try to address this problem by proposing the data model. So here, what is the model? Modeling means it's a standardization. We are going to standardize the data. If data is standardized, then it's easy to manage it and also easy to find such a data. If data, think about the room. If your room is really clean up, then it's easy to find your stuff. However, if your room is messed up, it's not standardized, then always you need to search everywhere. So it takes a time. So people try to standardize, model such a data because they are very slow compared to the memory base. So that is called the data model. So there are many different ways of data model. One of the way is why not? We consider this data as a set. So you know what is a set in mathematics. So in mathematics, set is like the A. Set A is 1, 2, 3. Or sometimes A is the x bar x equal the natural number like this. So it's a set. What is the benefit of using set? We can make the group. Like how many numbers do you have? How many integers do you have? It's an infinity number. Infinity is one of the main characteristics of the number. So we cannot list all the number. No way. It's not possible. Instead, we are going to define as a set. Then natural, when we are saying the real number, when we are saying the natural number, is actually set. So similar, when we have the many data, big data, and too many data, too much info, we are going to define such a data as a set. Instead of set, it's called a relation. So what is a relation? So it's a relation is a set of attributes or set of data. It's a simple definition, but it define what is the data. So in terms of a set of the attribute, because of that, during the database design, we are going to find the column attribute, name, ID, address for student data, or the professor ID, the course, and the rank, like that. So we are going to find this. After we find the attribute or schema, then we can find the data, like the instances, to make the database state. So this is called the relational database model. Then, once we have such a model, eventually we try to use computing resource, which means it should be implemented. So there is a software, it's called the DBMS. So DBMS is a software that implements such a data model. So if you have the DBMS based on the relational model, it's called the RDBMS. So we are talking about such a relational database management system, which is based on the RDB. The benefit of this relational database management system, RDB or RDBMS, is really consistent, as we discussed a lot before. Consistency. We believe the data. Whenever we process, like how many different types of process, We can create, insert the data. We can update the data. We can retrieve the data. We can delete the data. Mostly CRUD, the for operation. The database implements such a for operation. So whenever you are running such an operation, we still believe. Okay, just like you believe that your banking transaction, when you transfer data to your mom and dad, or receive the money from your friend, you believe. So it's because it's consistent. Like that, the relational database model is really consistent. However, as we discussed a lot before, to keep the consistency, there are a lot of things that happen. Okay? So we need to, it's not automatically done. We need to implement something to keep the consistency. That is the kind of the trade-off of the relational databases. So we need to manage the buffer management, version control, or we need to think about the log, journal, something. So to address that one, we have the NoSQL database. But still, because of the very strong consistency characteristic, or the transaction, in terms of transaction, it's called the ACID. So atomicity, consistency, isolation, and durability. So such a characteristic still, relational database is the most popular DBMS software. Okay. However, when we have the much bigger data, I know this is better, but this is not the possible when we have the petabyte size level, or even bigger than petabyte size level. We need to give up some part of the relational database. That is the NoSQL database, idea of the NoSQL database. So the rest of time, we do not have enough time to take a look at each and every part, but I'd like to highlight those who didn't take the database course, or those who take only the database design or the SQL part. There are much more much more characteristic in the relational database model that I'd like to introduce quickly in this class. Okay, so this is the relational database management system, DBMS. So for example, Oracle DB2 SQL Server such a software, which if they are based on the certain database model, like the relational model, we can say that this is the relational database management system. Like that. So that is the reason when I ask you to research on your selected database, NoSQL database, definitely you should include what kind of data model does your NoSQL database support. However, so when the ultimate goal of using database is we try to find the data. That's the most important part. If the finding data is just very slow, you don't have to use it. Okay? I know. We know the security or sometimes the durability is also important, but most important part of the database is searching the data very fast. But when we are saying the search, so there is another word in database is query. So search and query are very similar, but it's different in terms of database. Database guys use when you search the data from the database, it's not saying the search, instead it's called the query, the data. Because we are going to find the data which is standardized by the certain model. At that time, we call the query. However, if you just find the data from the non-structured or at that time we call the search, or sometimes it's called the retriever. Information retrieval. So IR is the user, for example, I'm going to ask you to use the Google search. We are not saying the Google query. Instead, it's the Google search. So you can find the data from the standardized, non-modeled data. Okay, so that is a different thing. Okay. Then also another thing you need to keep in mind: database or NoSQL database, also the relational database. Any database management system should be running on the operating system. From the operating system point of view, it's nothing but what? It's an application. So it's the application level. Also, it uses the resource of the operating system, like the file system and the memory, eventually CPU. So, you'd better understand such a performance or the characteristic of database from operating system point of view. So, why? Because it determine what is the benefit of using this database, what is the disadvantage of using this database. So because of what? It's an operating system. So that's the reason whenever I have been asked by the student or other people, what am I supposed to do? I'd like to be the database administrator, database engineer, database expertise. You need to know the computing architecture. And also you need to know operating system. You need to know the networks. So these are the fundamental to understand the database more. Then finally we have the database management system, but database management system, DBMS, is not only for the SQL. SQL is a very small part of your database management system. In addition to the SQL query, so there is a query engine, query processing, query optimization, and the concurrency control, transaction management, recovery, backup, and what else? There are more. These components are inside the DBMS. So somebody say, because of that characteristic, DBMS is more like very close to the operating system program. It has its own scheduling software. Okay. So I already talked about the data model and so on. So just like many other the language computer and the computer science application, so one of the main characteristics of the current computer science, the computer architecture, computing environment, computer program is abstraction. Because it's more and more complicated. So we cannot understand each and every step. Even hardware is a headache. So the approach is why not? The hide, the behind. We are going to focus on only API interface part, communication. I don't worry about what's going on, what the kind of movie you like. I need your help by communicating. So like you study, then I don't worry about the behind. Okay. For example, if I turn on the switch, what I need is interface. Turn on, off. Behind, I don't care the digital circuit, whatever. If I need to care about all of them, I cannot turn on the light because I need to worry about the power and the circuit design and everything. So one of the main approaches nowadays in computing is abstraction. Database is the same thing. Especially the DBMS system has 3 different layers of the abstraction as you learn. The external view and the conceptual view and the internal view as you learned before. Our goal is in the DBMS is the design goal is the conceptual view. But the DBMS focus on the internal view, physical level scheme. Then we spend a lot of time to understand our relational database management system there, transaction management, ACID. Hopefully, I believe you guys can understand what is the ACID nowadays. Okay. And also the DBMS, I didn't explain a lot regarding to the concurrency. Concurrent execution means the more like the synchronization problem. So, which means synchronization problem is when you have the shared data, multiple process access this, then it's the racing condition. They are fighting each other for the data. So same thing in a database, specifically database need very high level concurrency. Otherwise, you cannot support the multiple transactions at a time. So concurrency is done by the what? It's more like the isolation, which means the one database transaction does not bother the other data transaction. So I can access the same data like this is the balance. I can transfer, even I can my wife can withdraw the money. These two cannot bother. Okay. How can we do that? Isolation. Isolation means so you can see view the data within this one. Same thing for this. So you can implement a very high level concurrency control with the isolation. Okay. Then that doesn't make sense because eventually they are accessing the shared data, same data. To do that, we are going to schedule the transaction. What kind of a schedule? Very simple. It's a serial scheduling. One of the way is a serial scheduling. I didn't spend a lot of time for this part to run out of time in the advanced database design. But if you take a look at our textbook discuss very detailed what is a serial scheduling. So this is kind of the serial scheduling T1, T2, and Tn. The consistent data. So serial scheduling. So these are the list of the components implemented in the DBMS architecture. So each detail is mentioned. The rest of the slide, please take a look at if you want to review, and learn about such each component. But briefly, I'm going to introduce I'm going to brief each of them. The query optimization and execution means when you access the data, so I usually use the example of the traveling to or visiting the New York. So when you go to the New York from the Bridgeport, how many different ways? You can take the I-95, you can take the MTA, you can drive, you can also Greyhound, also you can take a walk. Bunch of different ways. Which one is the best one? When I'm saying the best means reliable. So if you have an interview 9:30 a.m. So even though driving is usually fast, but you don't want to be stuck I-95 because of the heavy traffic. It's not reliable. Instead, you probably take the train because even though it takes 1 hour 45 minutes to the Grand Central Station, 99.99% is still arrive on time. So you can plan. So query optimization and execution means they are not only just finding the fastest way, efficient, and also reliable way to access the data. So that is the purpose of the query optimization and query execution. Somebody said query optimization is kind of the brain of the DBMS system. It's an intelligent system. And also, eventually, they will access the files, the data, because still the majority of the DBMS system is they are using the persistent disk. In other words, a file. So how to access the file is important. As I mentioned many times, buffer management is also critical in the DBMS system because they want to speed up to access the data. How? So one is indexing. So and another one is query optimization. And however, those are not enough when you access data from the file system. So we are going to use the cache mechanism. So buffer is the memory. So we are going to use a lot, huge size of memory to speed up to access the data. However, NoSQL database, so you should be careful. NoSQL database does support some of the NoSQL database support in-memory database. Because it is true to speed up. As I said, the main purpose of using database system doesn't matter NoSQL database, it doesn't matter relational database. So any database needs efficient way of accessing the data. So memory, in-memory database is the most efficient way. However, if we are using the memory is volatile. So it's not reliable. We cannot lose. We may lose the consistency. So NoSQL database addresses such a problem by supporting in-memory database. So also disk space management and so on. Okay. So I'm going to stop here. So please read the next class. I'm going to spend 20 to 30 minutes at the beginning of class to explain briefly about the rest part of the relational database management system. Okay, then we continue the lecture for the NoSQL database. And also, please start the next page. I'm going to explain a little bit more details what you're gonna do in the next page, next task of the semester long the project based on the today's presentation. Okay, any questions? Any questions? Thanks so much for your attending, and thanks so much for your presentation. Please continue to work for the selected database, and hopefully you will get more experience and knowledge. And also one more thing, I will mention the next time. This is also a good idea to document on the research, like today's presentation and the implementation on the GitHub site. So I strongly suggest later I will talk about using GitHub as an extra point. So I'm thinking to give the extra point to those who are using the GitHub to manage the project. Okay, thanks so much, and stay safe, and good evening. Bye-bye.